Okay, part 2 then wants us to find the sum of these terms. So if you have a look at, even though they've written it as a sequence, that's going to be the sum of r over r plus 1 factorial. From r equals 1, that will give us the first term, 1 over 2 factorial, to n, which will give us n over n plus 1 factorial. It's always worth checking, not just assuming that it's going to be the sum of this from 1 to n, because sometimes they take off the first term or 2, sometimes this will be to n plus 1 or 2n, so it's just worth double checking that that's actually what we want. In this case it is, so we're fine. So then we're going to start writing down what the sum of each term will be, or what the value of each term will be. So when r is equal to 1, because this is equal to what we proved or showed in part 1, the sum of 1 over r factorial minus the sum of 1 over r plus 1 factorial, we can use this sum instead of this sum. So when r equals 1, we get 1 over 1 factorial, or just 1 over 1, minus 1 over 2 factorial. When r is 2, we're going to get 1 over 2 factorial, minus 1 over 3 factorial. When r is 3, sorry, that should be a 2. When r is 3, 1 over 3 factorial, minus 1 over 4 factorial. And you can see that the last term in each, last part of each term is going to cancel with the first part in the next term, and that's going to go all the way down to r equals n minus 1 and r equals n, the last term that we need to deal with. So the n minus 1th term is going to be 1 over n minus 1 factorial minus 1 over n minus 1 plus 1, so just 1 over n factorial. And when r is n, the very final term is going to be 1 over n factorial minus 1 over n plus 1 factorial. But as we said, all of these terms are going to cancel. Even this term here is going to cancel with this term here. So the only terms we're going to have left after everything's been cancelled is the very beginning of the first term and the very end bit of the last term. So that's going to be 1 over 1, which is 1, minus 1 over n plus 1 factorial.